Well, there is so much madness in the climate change world that I have countless stories to cover. But this series is something I'm going to concentrate on now, and it's something I will enjoy instead of having to cover ridiculous things and ridiculous claims. And so in this series, I'm going to take you on a journey. And some of the work is my work, but you always stand on the shoulders of others in science. So we're going to start off with simple examples. Now, this series is so everyone can follow it, from children to adults. So I'm assuming no knowledge. And I would like you very much to like it. But can I first of all ask, can you please press this button and subscribe? You know, there's so many people who watch me regular and don't subscribe. Now, we are a bit shadow banned on YouTube anyway, so we struggle to get the numbers. So if you could subscribe now, I'd appreciate it. But on with the series, and the first one is called The Innocence of CO2. Well, the journey for this series of videos starts with the Grand Canyon in the USA, a canyon that's over a mile deep in places, 6,000 feet to be more exact. So there is an extra mile or so of atmosphere above anyone at the bottom of the canyon, and that in itself makes it warmer. There are other factors as well, but that's a big one, that extra mile of atmosphere. And in fact, of course, compressing air does heat it up. Just try pumping up a bicycle tyre with an old-fashioned hand pump. You'll feel the heat in the tube. You feel it heat as you compress the air. And just like that with atmospheres, the higher and heavier the atmosphere, the more compression and the more heat there is at the bottom. In practice, of course, the height of the atmosphere and its composition contribute enormously to the temperature at the surface because they form the pressure at the surface. Now, this is a major factor in determining the temperature of Earth or any other planet in the solar system. The physics are the same everywhere. So let's ask a wizard to see if we can dream up a theory or law that can explain the temperature increase caused by this column of atmosphere, no matter where it is, no matter what planet it's on. Wow, well, there we are, the ideal gas law, formulated in 1834 and well established and accepted since. Well, this law is so basic and such a well-known thing, almost 200 years old, and not really challenged, accepted. Why haven't people used this as a starting point to get the temperature of a planet? Well, maybe it doesn't have any grant money to it. Maybe just using the normal physics I'm going to use now, which can explain temperatures quite precisely of planets, that they don't get any funds for it. That's the only reason I can think of, because this is relatively straightforward. Now, what I've done is I've written a paper on this, a scientific paper, which gives all the explanations and looks at different planets. Yeah. And a scientific paper done in layman's language, so it's two papers. It's the same paper, one's easier to read than the other. But for the scientific one, I have to be more precise. I have to give dozens of references of the scientists' papers I've used to come up with this. Now, you don't have to get involved with all the maths of this. It's straightforward. There are other factors besides the air pressure. For example, a big factor is how much sun is happening to that planet. So nearer to the sun, you're going to get more solar radiation. Further from the sun, you're going to get less. There are things that happen on planets, such as Mars has dust storms, and they can last for they can last for ages, years. And they really do change the average temperature as well. So you've got to take in the other factors as well, and my papers do. These are the two papers with that awfully long name. But you don't have to worry about that. What the paper has done is concentrate on a number of planets to prove that you can accurately find the average temperature, if you like, or about there, on almost any planet using just standard physics without the need for CO2 being involved at all. And what better planet to take to start with than Venus? Why? Because over 96% of Venus's atmosphere is CO2. Venus has a surface pressure over 92 times more than that on Earth. The CO2 is at 96.5%, which is 2,270 times that on Earth, which only has 0.0425%. You will hear that the alarmists claim all that huge amount of extra CO2, thousands of times that on Earth, causes an incredibly hot atmosphere. It doesn't. So if I can show you in simple mathematics using established physics that I can predict the temperature of Venus extremely accurately without any reference to CO2, I've blown it apart. And I can. And my paper simply takes the ideal gas formula, applies that, and applies the other factors of Venus, such as the radiation it's receiving from the sun, the amount it reflects back, its what we call its albedo, etc. If I can look at these little other factors and get it to over 99% accurate, my prediction, then I'm doing that without CO2. I've blown their thing apart, haven't I? I've blown their case apart. And I can. And that's what my paper does. And here are the results on Venus. Well, this is the table of results. One reading is taking at 1 bar. That's the same depth of atmosphere as we have on Earth, 1 bar. And there's a reading taken there and another reading taken at the surface. Now the 1 bar was 99% plus or minus 2% accurate, and the surface one was 99.5 plus or minus 2% accurate, if you like. So as near perfect as you can get a reading without CO2 being taken into account, just using the ideal gas formula plus other obvious things we know about, such as the radiation from the sun, etc. Now, using exactly the same method, Earth itself calculated at an accuracy of 94.3% plus or minus 3 as regards the recent temperatures, and over a long period, the Holocene, as explained in my paper, 99.7% accurate. Again, pretty well as near perfect as you can get, all without using CO2 to look at what the temperature is. Now, just quickly looking at the other results, we've got Mars coming in at 97.5%. We've got Jupiter coming in at 98%. We've got Titan. Now, I've used Titan. It's a moon, but I've used that because it's a large moon, like a planet, and it has a methane atmosphere. Now, methane's supposed to be a fantastic greenhouse gas. But here I've calculated the temperature using this simple physics method, with a 98% accuracy at 1 atmosphere deep, 1 Earth atmosphere deep, or at the surface 98.5%. Again, as near perfect as you can get. So you don't need CO2 and methane to predict these temperatures. So now, just looking back to what the claim is for the alarmists on this subject, here it is. The atmosphere of Venus is composed primarily of carbon dioxide, about 96.5%, and nitrogen, about 3.5%. There are trace elements of other gases, including sulfur dioxide, water vapor, and various other compounds. And here's the claim: the thick atmosphere contributes to an extreme greenhouse effect, leading to a very high surface temperature. No, the gravitational pull of a heavy atmosphere leads to that, and there may be other little variations you can put on it to allow for the individual characteristics of the planet, but that's it. So what this has done is shown you don't even need CO2 or methane in the calculations. Okay, so there we are. We've used the planets to take you to the different planets where there's a huge amount of CO2 or huge amount of methane, like on Titan, and it still doesn't influence the base temperature of the planets. But what the work does not explain, and by the way, the work is in the papers I've done, the same paper in layman's version, everyday language version, and another one in the more technical version, which is more precise for people to check. Those two are linked below this video. But I've only just settled, if you like, the base temperatures here, nothing to do with methane or CO2. What we're going to move on to in the next episode is look into Earth in more detail and actually come up with a better model for explaining the variations we've had, let's say, over the last 25 years than the climate models can. Okay, that's what we're going to do next. So thank you for watching. By all means, I encourage people to read the layman's paper at least. It'll give you some idea. Even if you only glance over it, it'll try to explain the work behind this video. And this is again just the first in a series of videos I'm doing where I'm going to concentrate on the science to show you that the science is not supporting the climate alarmists. It really, really isn't. Thank you for watching.